A is a constant, B is a constant, and C is a constant. Then log base A, B, is equal to C, and that's the logarithm form. And in exponential form, we have AC equals B. Exponential form. So that's a formal way of writing some of the very first thing that we learned. Now, I can also show you that if we have log base A, B equal to C, and if I take A to the exponent log base A, B equal A to the exponent C, then these two, the log A and its base A, cancel each other out, and we get B is equal to AC. So we can move back and forth between the logarithm equation and the exponential equation by transforming the expressions in this manner. Similarly, we could go the other way. We could take A to the power of C is equal to B, take log base A to the exponent C, log base A, B. These parts cancel each other out, and we've got C is equal to log base A, B. And that is what we have up there. So we can go back and forth. Now, from this property emerge three more properties, or three, I'll just say merge the three properties of, should be logs, or we'll say logarithms. Rule 1. If I have log base A, remember that's just some number, log base 5, log base 10, log base A, and I'll say B, some number B, plus log base A, some other number C, that's like writing log base A, BC. Where you can see I put BC in brackets because we can multiply B times C. So that's one rule right there. And sometimes you want to go from left to right, and sometimes you want to go from right to left. Rule 2, very similar to rule 1. Log A base A, B minus log base A, C is equal to log base A, B divided by C. Now let me give you an example for number 1. So for example, maybe we have log base 10, 10 plus log base 10, 2. That's like writing log base 10, 10 times 2, which is equal to log base 10, 20. And rule number 2, for example, if I have log base 10, well, this time I'll make it 12, minus log base 10, 2. That's like writing log base 10, 12 over 2, which is equal to log base 10, 6. And so those are 2 rules that you're going to need when you're working with logarithms. Now let's look at rule 3. Rule 3 says that if we have log base a, b to the power of c, then that's equivalent to c log base a, b. And so the exponent can move down in front. And I'm not going to give you proofs for these 3 rules, but you can find them on ALEKs if you're interested and you want to look at them. Let's put these rules to use. Looking at the first question, we have log base 4, and we want to solve for x over there. So what can we do? Well, we could say, well, we've got log base 4, 3 over 7, equal to log base 4 x. All right, so I used rule number 2, or property number 2. And now I'm going to raise both sides. Or I'm going to say that I'm going to take the base exponent 4 of both sides. So I'm going to be, well, I'll write it out. So I'm going to have 4 to the log base 4, 3 over 7 equals 4 to the log base 4 x. And then, of course, these parts are essentially going to cancel each other out. So we're going to be left with 3 over 7 is equal to x. Moving on to the next question, we've got y that we're going to try and solve. And everything is to the base log 3. So again, I'm going to use, I guess that looks like rule or property number 2, log 3, y divided by 4 is equal to log base 3, 28. I can do this same thing that I did over here, and except this time it's going to be raised to the exponent 3. When I do that, I'm just going to get y over 4 is equal to 28, and y is going to be equal to 28 times 4, which is equal to, pretty sure it's 112. I'll use my calculator and double check, and it is 112. Next problem, I'm looking to try and solve for z, and we've got log base 6. I can rewrite this as log base 6, 1 over 8 is equal to log base 6, 2 to the power of z. If I do that, and now I take 6 log base 6, 1 over 8 is equal to 6 log base 6 to z, I end up with just 1 over 8 is equal to 2 to the power of z. Maybe there's a few ways to go about this, but just looking at it, I know that the answer has to be z is equal to -3. If I wanted to try and algebraically solve this thing, I probably use the, well, let's use log base 10. So I've got log, take the log base 10 of both sides. So I'm going to have log base 10 1 over 8 is equal to z log base 10 2. And now I want to isolate that z, so I'm going to divide both sides of the expression by log 2. And I could get z is equal to log 1 over 8 divided by log 2. This is a very ugly thing to look at, but if I put it into my calculator, I do get z is equal to -3. Here we are on ALEKs, so let's take our answers that we worked through together and see if we've got the right ones. So the first question, the answer was 3 over 7. The second one, the answer was, oh shoot. And for the last one, the answer was -3. Let's see if we've got the right answers. And we do. Here's a question for you. See if you can solve it. Press pause on the video, give it a try, and then when you're ready, press play and we'll go through it together. All right, let's see what we can do. Well, to start, I would like to move my log base 4s to one side of the expression and see if I can simplify them. So I'm going to add log base 4 x minus 5 to both sides of the expression. So I've got this thing. And then I can use property number 1 of the log rules to rewrite this as log 4, or log base 4 x minus 2 times x minus 5. And that's equal to 1. Now I can use 4 as my base and the left-hand side and right-hand side as my exponents. So I can rewrite this whole thing as 4 log 4, the whole thing here again. Equals 4 to the exponent 1. And these two are going to essentially cancel each other out. And so I'm going to have x minus 2, x minus 5 is equal to 4. If x is equal to 1 or x is equal to 6, then this expression is going to be equal to 4. So we have two solutions.